name's Jim Paterson. I'm a principal of a group in Vancouver, Canada called Discovery Group. We have companies, both public and private, that are exploring projects around the world across the commodity spectrum. And innovation absolutely gives us an edge. And the industry has changed a lot over the last 25 years and will continue to change. Is moving fast right now. The two speakers that we have to my left, we've got Rob Wood, who's the commissioner at Geoscience Data Analytics Center, Saudi Arabia. Govind Friedland, who's a founder and executive chairman of GoviX Uranium Inc. So we'll start with you, Rob. Yep. Rob, could you just tell us a little bit about yourself, why you're here, why you're relevant, and we'll take it from there.
Sure. So thanks very much, Jim. I am the commissioner for the new Geoscience Data Analytics Center here in Saudi Arabia. And the intent is to be able to support greenfield exploration through to an inferred resource, and to be able to also do analysis around potential environmental impacts so that we can in fact actually support industry with early stage exploration, and to give confidence to companies that when they do in fact want to bid on projects, that there is already an environmental assessment that has taken place. So my expertise is in data science and building very large analytic platforms, and the greenfield exploration is a particular focus for us. Do you want me to go straight into the first question, or? No,
I'd like to pass it down to Govind to talk a little bit about yourself and tell us why you're here.
Thank you, Jim. It's a real pleasure to be here. This is my third Future Minerals Conference, so this is clearly becoming the preeminent mining conference on the planet. It's definitely on its trajectory. So it's a real honor and a privilege to be back. And, you know, my background, I'm a geologist. I'm a geological engineer from the Colorado School of Mines, which is our top mining school in the United States. And I've spent the last 2 decades exploring. We've worked in over 63 countries globally. So I've been involved in mineral exploration finance and building management teams and deploying capital across mostly energy transition metals. Most of my experience is in uranium and nickel and copper, but I've also worked in other commodities. Here you've seen a lot about Ivanhoe Electric, which has a joint venture with Ma'aden, and Taylor Melvin, the CEO, is here, but I was the first CEO of what's now Ivanhoe Electric, and we have a joint venture that's exploring here in the kingdom. We're deploying a special cutting edge mineral exploration technology, which is a geophysical exploration tool that separates all the hay from the needle. And Ivanhoe just announced their first results today, so that's very exciting. But geophysics is one of the most important tools that we use on a regional scale, because drilling can be very, it's intrusive. It's sort of like a CT scan. You don't want to just, cut your heart open, to look and see what's inside. You want to be able to see deep under the earth without touching the earth and have a very low environmental impact. And so we've been financing a lot of the tools for reinventing mining and reinventing exploration, starting all the way from the upstream, downstream. So it's a real honor and privilege to be here to talk about this topic, exploration.
That's great, and you were getting into Govind. Why do you think we're on the cusp of a new revolution in greenfield exploration, to build on your point, Rob?
Great. Do you want me to go first, Govind? Okay. So we're now at a point with technology that we actually are able to catch up to the geoscience. So we all understand that, any new tier 1 deposits are going to be deeper and undercover. We have for the last 15 plus years, a real understanding of mineral systems theory, and that continues to get more complex. And we're now at a place where, through different machine learning, artificial intelligence approaches, we can actually model all of those different deposit signatures and understand the fundamental characteristics that come into play associated with that. And we're really just at the very cusp of what's possible, and it's very much about de-risking greenfield. So much of greenfield has been, just a lottery of going out to the casino and hoping for the best. We're now at a place where we can actually use science to really hone in on high potential targets without doing a lot of wasted investment in early exploration.
That's great. So you're talking about the data side of the thing, but Govind, you've been at the forefront of collecting the data in the field, I would assume, with different technologies.
Well, if you look at the energy transition as described and the amount of metal that needs to be produced just for the electric car adoption. I mean, now copper is probably the most critical metal because no other metal conducts electricity or thermal conductivity as well as copper, except for precious metals, and much more expensive. So if you need to go from 25 million tons to 50 million tons of copper, that's more copper needs to be consumed in the next 20 years than has been mined historically since man started. So necessity needs to be the mother of invention. There's no way we can get there from here unless we change the way we've been doing things. And so fortunately, there's some very intelligent people and technologies out there that are disrupting the way that mineral deposits are found, and that needs to happen. There's no way we can get there from here unless we deploy new technologies, not just on the exploration side, but around the whole, the whole service supply chain, all the way down to the end user.
Yeah.
So I think it starts with geophysics is a critical part of it.
Yeah.
So I'm happy to speak more on that.
Yeah, we'll just bring it back because it generates a ton of data, lots of zeros and ones, and let's talk about maybe some of the powerful developments in AI technology and
sure
that will change the future of the business.
Yeah. So I guess a couple of things. Everybody has heard of ChatGPT as an example, large language models. There's particular types that relate to named entity recognition where we're actually building data architectures associated with geology that can autonomously populate data directly into a system, be able to make sure that all of it is geospatially located and also located by time, and that every single data point is correlated and associated to every other data point. It's incredibly powerful technology. It's the type of thing that, a geologist themselves, to try to go and read every report, all the geophysics, the drill holes, the geochemistry, it's actually past what human beings can do on their own. This is about dimensionality reduction to get to the right deposits and using technology to enable it.
Okay, so you've got a computer program. But
Yeah.
at some point, somebody has to drill, and you and I were talking about advances in drilling technology on the phone
Yeah.
yesterday, Govind. Maybe you can talk about that.
I'll come to that question, but I was recently in Beijing for a uranium conference, and one of the most interesting things I learned was they put a slide that was the head of the Chinese nuclear program. The Chinese are building more nuclear reactors than anybody, and they put on a chart of all the new electrical generating capacity that all the new nuclear power plants are going to build. And he said, but that's not the most interesting part. The most interesting part, in the second slide he put on, was the amount of electrical demand that will be put on the grid from AI.
Okay.
And the amount of electrical demand that is projected just for AI was more than the amount of nuclear energy that will be put on the grid from nuclear.
Wow.
Which is a staggering statistic.
Yeah.
Like how we use AI in mineral exploration is to analyze the terabits of data. Like with the Typhoon, we put electrical current in the ground, which charges up anything that's electrically conductive will absorb the electrical charge, like a battery. So we put current into the ground, And if there's metal, that'll absorb the electricity, and then when we turn the current off, it'll decay. Like the chargeability, we call the capacitance, will decay over time, and we measure how fast those decay curves occur. So if there's a slow decay curve, that means there's more chargeability, more metal. But we pick up all that data with geophones, and then we take that data into a supercomputer, and we use AI to correlate the geophysical, that raw data. We invert that data. We call inversion, data inversion. And that's what we use to actually create a shape that the geologists use to define a drilling program. Yeah. Because raw geophysical data isn't helpful unless it can actually create a shape of the underground, which is sort of analogous to like if you have a cancer and you're using a CT scan or like an MRI to image some cancer before the surgeon goes in and cuts you open. You want to know exactly where it is. That's what we're using AI for, is to analyze the geophysical data before we drill.
Right.
So that short circuits the amount of time, and we don't actually, it addresses one of the biggest inefficiencies in mineral exploration, which is drilling.
Yeah.
There's been recently a study, S&P study, from 2002 until 2022, the last, say the last 2 decades, of 127 mines that were brought into production globally. Of the last 127 mines, it looked at copper, it looked at gold, and it looked at all other mines. I wish I had the slide to put up. But on average, between copper, gold, and all other mines, it was 16 years from discovery to production, and that's all drilling.
Exactly.
You know, that's a huge amount of time. We don't have 16 years. We can't wait 16 years to bring on twice as much copper. Like there's no way we can get there from here. So we have to change the way we not only explore using geophysics, but also drilling.
Yeah.
And one of my colleagues, he's here. So I'll give a plug for him. He has a company called ExtremeX. They reinvented the way that for oil and gas they drill. Now it's maybe in Saudi Arabia it's about 80 or 90% of the drilling is using coil tube drilling, but in the mining industry we use conventional rotary drilling. And every time you go down, you have to tip another, pipe, so tighten it. And if there's a problem, you got to pull your whole drill stem back up. It's the drilling industry for mining is not changed in 70 years.
Right.
And all the really good drillers from the 80s and 90s are all dead. There's nobody around. So drilling is actually one of the big pinch points in order to not just get a quality driller, but it's expensive, takes a long time, and all the really good drillers are basically gone. So the mining industry needs to pull a feather out of the hat from the oil and gas industry and use similar technologies, but the mining industry is notorious for being very risk averse to adopting new technologies.
100%.
But it's about time that we look to our oil and gas brothers and adopt some of that technology, or there's just no way we're going to get there from here.
Yeah, exactly. So other than drilling, what other ways do you see advanced AI de-risking exploration?
So just picking up a bit on what Govind said there, we can't keep going along in the same approaches to exploration that we have for the last 30 years. We know how many tier 1 deposits we've found doing it that way, and it's not working, right? Using AI will allow us to move in a different direction. And you think about the compute power, one of the really leading areas is around what they call multimodal learning. So what you're doing is, the simplest example I could give you is, it's a good-looking cat. I can take a picture of it, and I can do some analysis to say that one actually is a good-looking cat. I can give it a number and a score, and I can also give it language. What you're doing is you're actually taking everything from remote sensing data, geochemistry, drill hole data, the geophysics, looking at, lithospheric architectures and, underlying characteristics of alteration minerals and structures and lithologies, and you pull it all together to go and build out models that will give us the highest potential, targets that we can go and work on. So, I'm a firm believer that, do the analytics first. It still requires geologists to do significant interpretation, but spend the time up front before you ever go and stick a drill in the ground.
That's great.
Yeah.
So I've heard we've got 5 minutes left. We'd like to take a couple questions from the audience. We've got time for 2. Do you have a question, sir? We'll give you a microphone.
Thank you very much. Govind, you talked about using a CT scan to see what's underneath. And a lot of the AI new AI, is not as helpful as old AI, stochastic processes kind of AI. From discovery to better drilling. There's a disconnect between a lot of innovative companies, I know 100 in Sweden, and the big guys who resist innovation. As you said, mining is a risk-oriented thing. How do you make that connection to make more intelligent those brilliant things your father talked about, GPulse, etc., where it's a great realm of application to add AI to what GPulse does? How do you make that connection to stop the distortion flow of capital that's resistant to that kind of innovation?
How do you make the connection? Do you understand?
If I understand correctly, between the big companies and the juniors?
Between, let's say, Ivanhoe and 100 Swedish innovators.
Okay. Well, I think what you're talking about is the difference between AI and and human intelligence. And with human, there's no substitute for human intelligence.
No.
I mean, the geologists need to be on the ground. Like I talked about the geophysics, but that's just one piece. The geochemistry, the geology. Geologists are more like artists than real scientists. They have to look at all of the different data, and that's ultimately, it's the geologist that picks where you drill. So I think when we look at the whole suite across the mining industry, the sort of juniors and mid caps and large caps, the way I reconcile it is the major mining companies, and they're here, but they actually very rarely make a mineral discovery. It's usually, the best analogy is sort of like the biotech drug industry. It's usually a junior biotech company that's trying to prove that some new drug is efficacious. Once they prove it to the Food and Drug Administration, the majors come and buy it. So it's sort of the way that the industry is set up. Most of the major discoveries are made by the juniors, and I mean, I think what you're talking about is access to capital. That's a separate thing. Access to capital nowadays is extremely difficult. I mean, we're being starved of capital to make these major discoveries, which need to be done. And so, that's a whole other industry. That's a whole other question, as to how can, I mean, if you look at mining as a whole, it's about 1% of the U.S. S&P.
Okay.
Right, which is a tiny little fraction of the whole industry, but there'll be no car industry without mining, right? There's no, you cannot have a renewable industry like wind and solar without mining. So the S&P should, mining should be like over 10%. It's now like 1%. And so like, how do you change that? So you need to build more awareness, I think, in the investment community. People need to understand why it's more important, like why are minerals critical? And the U.S. State Department, they've just sort of woken up. There's a strategic petroleum reserve, but no strategic minerals reserve. And they're like, okay, like so that this is right. It's all of a sudden it's becoming really urgent, which is why you see the State Department now much more active in Africa. They've just woken up, basically since COVID, and they realized well, we don't actually produce these minerals domestically. We have to source them abroad in friendly jurisdictions.
Yeah.
So I'll pause there.
Yeah, I think final words from you, and then we're done.
Sure.
Yeah. Thank you, Govind.
So I think, part of you mentioned juniors, and the junior market has struggled, for a number of years. And I think it's in part because, they don't have access to the kinds of technology that actually will allow them to be able to find new discoveries with less money, right? They're still having to invest significant money up front. And the kind of technology that we're talking about is very open, right? It lives in the cloud, it will become open source, and we're going to actually have, I think, a new era of exploration that's going to come out over the next, and I'm not talking tomorrow, I'm thinking in the next 5 to 10 years. That's kind of where it's going.
And I'll give a plug to the country in which we're in. They will be leading the charge.
There's no doubt.
They are making the investment to lead us into the future. Can I have a warm round of applause for Rob Wood and Govind Friedland?
Thank you.